Good evening, everyone. JNV Yanam, JNV Gondia, I think. So, good evening, everyone. So, today uh, we will start third lecture of thermodynamics. And in the previous lecture, we have completed first law of thermodynamics. That was the highlight of the previous session. The first law of thermodynamics. After that, we have done some concept test questions, and again after that, I think we have completed the isobaric process. So today, in the today's session, what we will do, first of all, we will have a recall test. After that, there will be some discussion of the topics like isochoric process, isothermal process, and then there will be a quiz. Uh, Try to notice one thing in this lecture. Actually, the level of the question is going to be a bit higher. So be focused, actually, because I am not going to do some class 11 questions. The questions will be of class 11, syllabus of class 11. Syllabus is of thermody, but the level is going to be a bit higher side. So be prepared for that. Try to maintain your focus. Otherwise, if you lose a 1 minute of your focus or few seconds of your focus, then the question will be gone. So try to be attentive in the class. This is the disclaimer that I am putting in front of you before the class. So today's session is more based on numerical approach, uh, along with some theory part, but numerical approach is going to be discussed today. So be ready for that. First of all, let's start with the recall test. Recall test, there are, I have put two recall tests. Let's take a look. In the first question, these four options, these are not four options actually. You have to find out true and false statement out of these four, which is true and which is false. So you can write your answer like this way. I think first of all, you have 40 seconds. You need to mention true and false. How you can answer? You can answer A is true, B is false, C is true, D is false. Whatever is the answer, you can answer in that way. You have 40 seconds to answer. Okay. Read out each statement. The first statement is heat given to a system is considered positive. Okay, so in the previous section, when we have studied first law of thermody, there we have used some sign convention. So this is the question of clearly a question of sign convention. So heat given to a system, what we have considered it positive. So the statement is correct. If the statement is correct, so we will write it as true. We will write it as true. Next statement is first law of thermody is based on conservation of heat. It's conservation of heat. Heat is a form of energy. So what is it? Conservation of energy is actual conservation law. Conservation of heat is nothing. You know that, na? Conservation of heat is just a form of energy. So conservation of heat is no statement, no conservation law is mentioned like conservation of heat. Statement B is false. What is the actual statement? Conservation of energy. Again, next question is, or next statement is, heat rejected by the system is positive. No, heat given to the system is positive and heat rejected by the system is negative. So this statement is again false. Next statement, work done on the system is positive. Work done on the system means compression. Work done on the system means compression. So whenever there is a compression, the work done should be negative, but the statement says positive. This is again false. So from this question, I hope I am able to recall the sign conventions. I hope that sign conventions are clear to you of the previous class. Clear? So try to remember. Now we will do a question which is a little bit on higher side. Okay, moving further. Try to be active actually. Don't sit like that. I don't know what's the problem, what's the environment in your class, how you are studying, but at least there should be a response from your side like, yes, sir, I got the question, move further. Whenever I say I'm moving further, you can say yes. You can type at least Y in that portion. That will be better. Okay, otherwise I might think that you are still noticing the question, you are still understanding the concept. That shouldn't be there. Okay, another question. First thing, the question is from H.C. Verma. H.C. Verma. Okay. And you need at least 1 minute of time to solve this question. 1 minute at least you will need to solve the question. Okay, try solving it out. I am expecting at least one or two answers here. I am just keeping quiet. Should I start or you are able to solve it? Okay, let me start. So first of all, we will read the question. A sample of ideal gas is taken through the cyclic process ABCA. Okay. ABCA, this is a cyclic process. Done. It absorbs 50 joule of heat. First of all, whenever you see a question of thermodynamics in your exam, try to uh, write down the data because you will not have sufficient time to reread the question. Then the language is going to be too long sometimes. So try to uh, try to write down the data. Okay, first thing is that. So I am going to write down the data. It absorbs 50 joule of heat during AB. Okay, absorbs. Absorbs means heat is absorbed by the system. Matlab heat is given to the system during the process AB. So find out the process AB, and in this process AB, heat Q is 50 joule. Now you should answer whether it is going to be positive or negative. Because heat is given to the system, that means it is going to be positive. I think it is clear. So I am writing the data at the process itself. Heat given to the system is 50 joule. Now read the next statement. No heat during BC. That means B to C, Q is 0, clear? And rejects 70 joule of heat during CA. So during CA, reject करती है 670 joule of energy. So Q is going to be minus 70 joule. I think till now every statement is clear. Next statement is 40 joule of work is done on the gas during BC. Now again you can read it out on the gas. On the gas is again negative. So 40 joule of work is done on the gas during BC. So BC is this process. Work done is minus 40 joule. I think clear. Again, next statement is the internal energy of gas at A is 1500 joule. So at A, that means at this point, U is equals to 1500 joule. I think each and every statement is clear till now. I have mentioned everything that is given in the question. Now, the work done by the gas during the process CA. CA is the process in which work done is asked. Can you identify the process CA? Can you identify the process CA? Yes, we can identify because in the process CA, the pressure is constant. This is PV graph, and at every point of CA, you can see pressure is constant. And if pressure is constant, so this is going to be isobaric process. Can you see that? So what we will do, C2A process. Work done will, I can see, you can apply first law of thermodynamics. And what is this? Q is equals to delta U plus W. Is it clear? Now, Q is equals to delta U is what? We are going for C2A process. So final minus initial. So final is what? UA minus UC plus W. That's what is the first law of thermodynamics. Clear? So now we need to calculate work done. So work done will be, I will change the color of the pen. Work done will be Q minus UA minus UC. Let it be equation number 1. Now, in the process CA, Q is given, that is known. UA is known. If you can calculate UC, UC is what? Internal energy at C. Then the question will be solved. So our focus now shifts towards calculating the internal energy at C. Till now, I hope every point is clear. So now our focus has shifted. We can put all these values. Q is known, UA is known, UC is to be calculated. So we will shift our focus now. Internal energy at A is given, but B and C are unknown. Okay. So now listen to me. For the process AB, for the process AB, can you see that Q is equals to delta U plus W? This is again first law of thermodynamics. Q is what? You will say 50. This is mentioned here. Q is 50 is equals to delta U is what? UB minus UA plus W is what? W is the work done. And you can see that AB is the process in which volume remains constant. In which volume remains constant. If volume is constant, that means that work done will be 0 plus 0. So you can write it as UB is what? 50 plus UA, and UA is what? 1500. So what we have calculated as UB is equals to 1550 joule. So what we have calculated potential, sorry, internal energy at B. Now, again for the process B to C, you might find it out that the question is very lengthy. It's not going to be possible for us to solve. But believe me, these questions are on easier side. You can easily solve these questions. I am taking a longer time because I am explaining it to you. But if you do it by yourself, you will take a smaller time. You will take a shorter time to solve it. For the process BC, again, I am applying first law. That is Q is equals to, again, delta U is what? UC minus UB plus W. The question says Q is equals to 0 is equals to UC minus UB plus W is what? Minus 40. If you calculate it, UC will be UB plus 40. That means 1590 joule. We needed internal energy at C. Now we can place this value in equation number 1. From equation number 1, if I place these values, then W is equals to Q is what? Minus 70 minus UA is what? 1500 minus UC is what? 1590. If you can solve it out, it will be minus 90 minus plus 90 minus 70. W is equals to 20 joule. W is equals to 20 joule. So this 20 joule is going to be our answer, which is going to be option number D, 20 joule. What can you say about this question? Is it on the tougher side or is it okay for you? I don't think that it's on tougher side. It's easier side. You can easily solve it out, but you need to figure it out. Try to ask if you have any doubt. I will move further if you can ask. Otherwise, I will move further. Okay. This is the same question. Isochoric process. Now, this is the conceptual part that we will discuss. Concept. Isochoric process. The definition is very much clear. The process in which volume remains constant. So there is no problem with that. If I say that for an isochoric process or for an ideal gas, PV is equals to nRT. Here V is constant, N and R is also constant. So P is proportional to T. P is proportional to T means P1 over P2 is going to be equal T1 over T2. There is no problem with that. P1 over P2 is equals to T1 over T2. You need to remember these terms. These terms needed to be remembered actually because they are used in the numerical sections. Otherwise, you will stuck in some questions, some situations you might stuck. So Try to remember these things or try to figure it out. Okay. So isochoric process, what we have learned, P is proportional to T. Okay. Now we will draw some indicator diagrams for the isochoric process. Okay. First is PV diagram. Whenever I say PV diagram, volume is constant. And for volume constant, P is proportional to T. These two things we have learned. One is V is constant. If V is constant, you will say in the complete process, volume should remain constant. So the graph should be like that. In this case, the indicator diagram, the arrow shows that pressure is decreasing, but the volume remains constant. This is the first indicator diagram. Another diagram may be like pressure and temperature diagram. If you see P and T, in case of P and T, P is proportional to T. If P is proportional to T, it should be like that. And the graph should be a straight line passing through the origin. This is our PT graph, PT indicator diagram. Now again, if I repeat the same thing, we have assumed pressure to be decreasing. So I am also assuming pressure to be decreasing here. Clear? Again, there is a next graph, that is volume and temperature graph. Again, I am saying that volume is constant, then graph should be like that. Volume is constant at every point. What should be the direction of arrow? Is it going to be left or going to be right? Is it going to be left or going to be right? According to these two graphs, you can see if pressure is decreasing, then temperature is also decreasing. So temperature is also decreasing. Clear? I think every point is clear till now. Now, work done in isochoric process. This is the simplest part of this derivation of this process. Work done in isochoric process, what we have learned, work done is equals to integration PdV from V1 to V2. And for that, we have calculated PV, limit is V1 to V2. Now, V1 and V2, for the isochoric process, V1 and V2 are same. For the isochoric process, V1 and V2 are same. So work done will be P V2 minus V1, and which is going to be 0. So you can remember it out that for isochoric process, work done is going to be 0. These things to be remembered. For isochoric process, work done is 0. I think clear at this point. Up to this point, everything is clear. Moving further. So what are the three things for the isochoric process? What are the three things? First thing is volume is constant. Second thing is P is proportional to T. Third thing is work done is 0. Clear? Moving further. Try to note it down. Again, the isothermal process. We are doing it quickly. Isothermal process. What is the isothermal process? The process in which temperature remains constant. The process in which temperature remains constant. Again, we can write it as PV is equals to nRT. If temperature is constant, N and R are also constant. N is the number of moles, R is the gas constant. So the complete RHS is constant. So what is going to be the conclusion? That PV is equals to constant. PV is equals to constant. Clear? If PV is equals to constant, you can write it as P1 V1 is equals to P2 V2. I think there is no problem with that, na? P1 V1 is equals to P2 V2. I think it is clear. Okay. Now, we will draw some indicator diagram for the isothermal process. First is PV diagram. What is the relation between P and V? You can say P and V, the relation between P and V is PV is equals to constant, which is going to be a hyperbola, which is going to be a hyperbola, and it will look like something this one. I am drawing it for the expansion part, PV, and you can see that in the process, volume is increasing from here to here, volume is increasing. So this is called isothermal expansion. This is called isothermal expansion. This is the representation of hyperbola or PV equals to constant. Next graph is P and TK against the P and T. So temperature is going to be constant now. So I will draw the graph something like that. There is no issue. In this line, temperature is constant. You can see it will have same value as this point. Temperature is constant. Now again, I will ask you to put the value of the arrow for the PT graph for the isothermal expansion. This is what isothermal expansion. You can see that volume is increasing, but pressure is decreasing. So pressure is decreasing means you can put the arrow like that because pressure is decreasing. Another graph will be between volume and temperature. Again, temperature is constant, so graph is going to be the same, V and T. And this is going to be the again the same temperature like T naught. On the complete process, temperature is going to be remain constant, that is going to be T naught. Now, what should be the sign of the arrow? Because isothermal expansion volume is increasing, so volume is increasing means volume is increasing. This is process AB, process AB, process, sorry, AB. Clear? Again, moving further. Now the conditions for isothermal process. These are again two important things that you should notice here. What are the conditions for isothermal process? Now notice. Consider this is a thermodynamic system fitted with a piston, and there is some ideal gas filled in it. So what I'm saying, in the complete process, temperature should remain constant. Temperature should remain constant. And what we have learned till now, listen to me very carefully. If I try to compress this piston, listen to me very carefully. If I compress this piston to this position, this is initial position A, this is final position B. If I try to compress the piston, then due to this compression, the internal energy of the molecules might increase due to the collisions with the wall. So internal energy might increase. So if the internal energy is increasing, then you can say temperature will increase, but the temperature should remain constant. That's the condition. So for that, what you want, first thing is clear. If you compress the piston, then the temperature of the gas will increase. If you compress something, then its temperature sometimes increases, and sometimes you can feel it. The temperature is increasing. So for that, what you should do, that the extra heat generated here should transfer outside, should transfer outside. Or if I reverse it, reverse the process, that if I expand the gas, then its temperature will cool down, its temperature will decrease. Then what should be required? the extra heat should come from outside. That means there should be a medium through which heat can be transferred. And that is our first condition. What is going to be the first condition? That walls of the system should be conducting. Conducting means diathermic. So what is the condition? Walls should be diathermic so that it can exchange heat with the surrounding to keep the temperature constant. Next condition. Have you ever mixed hot water with cold water? Ever hot water with cold water? In that case, you can see that finally, after some time, after some time of mixing, the temperature of the complete liquid, complete water becomes same. But just after the mixing, you can see the temperature of whole water is not same. Somewhere it's warmer, somewhere it's colder. So it takes some time for the transmission of heat, for the achievement of equilibrium. That means if I want the temperature to be constant at every time, then I should compress or expand the system slowly so that it might get some time for the transmission of heat for to attain the equilibrium at every instant. So the second condition is the process must be slow. The process should be slow so that it may get some time for the transfer of heat. So these are the two necessary conditions for the isothermal process. What are the two conditions? First is walls should be conducting. Conducting is diathermic. And second condition is process should be slow. Process should be slow. Next. Till then, if you have any doubt, you can ask. Work done in an isothermal process. Okay. So we will calculate the work done in the isothermal process. Okay. Listen to me. What we know that work done is equals to integration P dV from V1 to V2. This is our first equation. This is what we know that for every condition, every situation, this is the work done. Now, P, if you remember in the case of isobaric process, P was constant. So we have taken P outside of integration. But here P is not constant. If P is not constant, what is the possibility? We know that what we know that PV is equals to nRT. So what is going to be the value of P? P is going to be nRT by V. Is it clear? P is what? nRT by V. I will place this value of P in the first equation. And you can again notice the numerator. N is number of moles, R is gas constant, and T is constant according to isothermal condition. So the numerator is constant. I will place this P in equation number 1. From equation number 1. Work done is what? P is placed as nRT by V, and I will take nRT as a constant outside of integration. That will be nRT integration 1 by V dV. From where to where? From V1 to V2. Again, if you can see, work done is equals to nRT. 1 upon V integration is what? Ln of V from where to where? From V1 to V2. Clear? Now I can put the limits. So work done is what? nRT ln V2 by V1. This is our work done for the isothermal process. nRT ln V2 by V1. Now, sometimes the volume is not given, pressure is given in the question. So then we can transform this relation. How can we transform this relation? We again know that what we have seen that P1 V1 is equals to P2 V2 for isothermal process. Then V2 by V1 is what? P1 by P2. So you can replace this value and you will get work done is equals to nRT ln P1 by P2. If you have any doubt, you can ask me. This is the simplest form of derivation, and this is the mostly asked question is from these relations. Isothermal process, work done in isothermal process is the mostly or widely asked question in any exam, like in JEE, NEET, everywhere. They ask the question from isothermal process, that's for sure. And you need to use these formulas for sure. I think it is clear now. Can we move further? Work done in isothermal process is done. So isothermal process is done. Isobaric process is done. Isochoric process is done. Work done in isothermal process, conditions of isothermal process, and indicator diagrams. Everything is sorted till now. Try to note down these formulas so that whenever you try to solve the questions, you can easily use these formulas. If you can't remember these formulas, you at least can write these formulas so that it will be easier for you to at least attempt the question. Otherwise, it will be difficult for you that from where you, sir, you can put these formulas. So try to write it down. This one suggestion from my side. Now we are going to start some quiz questions. Some questions at least you will say the questions that are going to be on a tougher side, on a mediocre side. Not, I'm not saying on the tougher side, but from moderate, from easy to moderate side. Okay. First question on your screen. This is the easiest question. This is the easiest question of all. So you can solve it out in 1 minute. No problem with that. Try to read out. You got the answer, you can comment in the chat box. A, B, C, D. I think after that, There is one more question. One more question. So there are two more questions after this one. Try to solve it. Okay. So you are not answering. Okay, sorry. First of all, read the question. 2 moles. Okay, so try to remember n is equals to 2 given. An ideal monoatomic gas undergoes a cyclic process as shown. Some cyclic process is shown here. Pressure in different states are okay. So at all these states, temperature is given at least. At state 1, state 2, state 3, state 4. Can you calculate the temperature in all these states? You can easily say that. You can say that T1 is what? T1 is what? 6 T1 is 1800. So T1 is what? 300. T2 is what? 600. T3 is what? 1800. And T4 is what? 900. I think this is not a difficult part for you, no? This equation gives the temperature of all the states. State 1, state 2, state 3, and state 4. Clear? Determine the work done by the gas during the cycle. Complete cyclic process के लिए work done बताना है. Now, someone of you, the thing that may come in your mind, sir, calculate the area of the trapezium and we will get the work done. There might be a thought in your mind that calculate the area. This is going to be a trapezium, na? Calculate the area of trapezium and we will get the work done. But listen to me, that was on the PV indicator diagram. The area thing was related to the PV diagram, but this is not PV diagram. This is PT diagram, pressure and temperature. So try to make sure that whenever you are trying to calculate the area, then the graph should be in P and V. So that is not going to be the solution here. Okay. Mayuraj is saying hi. Hi, Mayuraj. Okay. Now, again, so we have to identify the processes. Now, I am marking the process. Let's suppose this is process 1, process 2, process 3, and process 4. So, complete work done is going to be what? The work done of all the processes. Is it clear? The sum of all the work done is what? Complete work done. Okay. Now, identify the process. You can see that for the process 2, the graph is starting from the origin, which means P is proportional to T. And if P is proportional to T, that means this is isochoric process and you should identify these equations. So what I can say that process 2, similarly the process 4 and process 4 are isochoric. Are isochoric. If they are isochoric, that means work done in second process and work done in fourth process is 0. Clear? So two work dones are cancelled. Now we have to calculate only W1 and W3. We have to calculate only W1 and W3. So what is work done in first process? This is going to be isobaric process. This is going to be isobaric process. So I am going to calculate work done in first process. W1 is equals to isobaric process work done is what? P delta V. That's what we have learned. That is P V2 minus V1. Can you see that? Delta V is what? V2 minus V1. But volume is not given. Volume is not given. You can write it as PV2 minus PV1. I think this is clear. PV2 minus PV1. From ideal gas equation, PV is equals to nRT. PV is equals to what? nRT. So you can write it as nR T2 minus nR T1. So W1 is nothing but nR T2 minus T1. Now you know the values of T2, you know the value of T1. You can put it here. So W1 is equals to N is what? 2 moles R, and T2 minus T1 is what? 300. So W1 is equals to 600 R. This is W1. Now you can calculate W2. I am going to calculate W2 here. W2 is what? Again, W2 was 0. So I am going to calculate this is first, second, third, and fourth process. So I am going to calculate W3. This is again isobaric process. So again work done will be P, and delta V is what? V4 minus V3. Again you can say PV4 minus PV3. PV is equals to nRT. So it will be nRT4 minus nRT3. You can take nR as common, T4 minus T3. N is 2, R is what? R. And what is the value of T4 minus T3? You can see T4 and T3 were. T4 is 900, T3 is 1800. So 900 minus 1800. What will be the answer? That will be minus 1800 R. This is W3. So the total work done is what? W1 plus W3. W2 and W4 were 0. So total work done is what? W1 is what we have calculated. W1 600 R. 600 R. This is minus 1800 R. So the right answer is minus 1200 R. Minus 1200 R. Minus 1200 R, which is the option? Minus 1200 R is the D option. Is the option number D. Okay, so this is the easier question. We have taken a longer steps, or we have not skipped any of these steps. That's why it seems longer to you. But if you practice, then it will be a question of at least only 3 or 4 lines. Only in 3 or 4 lines you can solve it out. I think it is clear. Now moving further, you can understand the things. Moving further, we can take one more question. Okay. This is again a very important question. Very, very important question. Might be difficult for you. Okay. The question says, in this question, there is only language. That's what I am trying to teach you, that sometimes you will see only language and you might skip it. You have a tendency, you will have the tendency at that time to skip the question because you will say it's a longer question. How much should I read it? I will waste my time. But the question is on the easier side. Okay. A sample of an ideal gas has pressure P naught, volume V naught, and temperature T naught. Okay. It is isothermally expanded to twice its original volume. Okay. So first of all, there is an isothermal expansion. So first of all, should I draw a PV diagram? Okay, let's try. Let's try it out. Okay. I am just roughly drawing a PV diagram. This is pressure, this is volume. So that we can remember the things. Now, otherwise, how to write these things? Are you getting my point? So I will draw a PV diagram which will help me out in remembering the things. That's why I'm drawing it. What it says, it is isothermally expanded. Okay. So isothermal expansion should look like that. That's what we know, that this is isothermal expansion. Let's suppose from an initial state A to a final state B. This is isothermally expanded. And initially they are saying that the pressure is P naught, volume is V naught, and temperature is T naught. Clear? And at the point B, they said that it is isothermally expanded up to a point B where twice its original volume. So volume here is 2V naught. What about the temperature here? You will say isothermally expanded. And if isothermally expanded, then temperature will remain same. Only the pressure thing that we don't know. So we don't know the pressure here. Volume is 2V naught, temperature is T naught. Clear. After that, it is then compressed at constant pressure to have the original volume V naught. It is then compressed. It is then compressed to have the original volume and compressed at constant pressure. Constant pressure compression will look like that. So at this point, volume is again V naught. Clear? Finally, and constant pressure, that means pressure should remain constant. Finally, the gas is heated at constant volume to get the original temperature. If get the original temperature, that means gas should reach the same point. And this is isochoric process. So that's a quite simple question. Now we have drawn the PV diagram. What they are asking, the work done in the process will be, so they are asking about complete work done. Let's suppose this is work done 1, this is work done 2, this is work done 3. So they are asking about complete work done. Complete work done is what? The addition of all these three. Out of which you can see W3 is going to be 0 because this is going to be isochoric process. You can see that this is the isochoric process. So work done in isochoric process is 0. Okay, so let's start. Okay. Okay. So first of all, we will calculate work 1, then calculate W2, and W3 is already known. So no problem with that. W1 is what? This is isothermal process. And for isothermal process, what we have learned, work done is equals to N R T ln V2 by V1. V2 by V1 means final volume divided by initial volume. And if you see final volume is 2V naught, initial volume is V naught. And if you divide these two terms, you will get 2. You will get 2. I think this point is clear now. Clear? Now, what is the temperature? In the complete process, temperature is T naught. Temperature is T naught. I think till now everything is sorted. So W1 is here, NR T naught ln2. But if you can see, in all these options, temperature is not mentioned. Temperature is not mentioned. There is no issue with that. You can see that from ideal gas equation, you can see that we have to eliminate this term. Na? So W1 is going to be PV is equals to nRT. PV is equals to nRT. So we can write it as P naught V naught ln 2. This is our work 1. Now what is going to be work 2? Work done in second process, W2. This is process, let's suppose this is C. BC process. In the process BC, you can see that this is isobaric process. Na? So in the isobaric process work done is P and delta V. Delta V is what? V naught minus 2V naught. Final minus initial. Final minus initial. So now we have to put the value of P here. If we can put the value of P, then total work done can be calculated easily. So the pressure at this point can be calculated as, you can see, this is the main thing that you should learn. This is the main thing that you should learn actually. Okay. For process AB, this is isothermal process. Now, we need to find the relation of the pressure. However, volume is given in these two situations. So we can use that for isothermal process. P1 V1 is equals to P2 V2. P1 is what? P naught. V1 is what? V naught. P2 is what? Pata nahi. V2 is what? 2V naught. V naught cancelled out. So P2 is what? P naught Y. Can you see that? Here the pressure is going to be P naught by 2. So I will replace the value. W2 is equals to, let's suppose this is P2. P naught by 2, and this is minus V naught. So W1 is known, W2 is known. So total work done, and W3 is what? W3 is what? 0. Why 0? Because this is isochoric process. Now total work done is what? Total work done is what? You need to add all these W1, W2, and W3. So W1, W2, W3, if you add, it will become P naught, V naught, ln2 minus P naught, V naught by 2. Okay, you can take something common out of it. P naught, V naught by 2. If you take it common, so it will be 2 ln2 minus 1. This is total work done. Which option is correct then? P naught V naught by 2, 2 ln2 minus 1. P naught V naught by 2, 2 ln2 minus 1. This is option number B. Now I can see that the concept is clear to you. Again, this is important question. These are important questions actually. In the next session, we will start some specific heat concept, the degrees of freedom, the adiabatic process, the adiabatic constant, uh, from where the lot of question actually came in the previous years. If you can solve these questions, then there is a certainty that you can solve the question in the examination. In the JE examination, I am talking about. I think till now everything is clear. So I am ending the session here. Time is already up. So I hope you enjoyed the session. Bye bye, everyone.